Number 56 is an algebra question, and it tests your ability to graph inequalities. Each of the following graphs in the standard xy coordinate plane has the same scale on both axes. One graph is the graph of ax plus by is less than or equal to c, where 0 is less than a, which is less than b, which is less than c. Which one is it? Notice first that this is a linear inequality. They give it to us in standard form. Ax plus by is less than or equal to c. Notice also that a, b, and c are all positive, but a is less than b and b is less than c. The easiest way to approach this is to plug in your own numbers. I will use 1, 2, and 4 for a, b, and c. So if we rewrite this inequality, it will be 1x plus 2y is less than or equal to 4. We are going to isolate the y. We want to put this into y equals mx plus b form, or slope-intercept form. So we'll bring the 1x over. That's 2y is less than or equal to negative 1x plus 4. Divide everything by 2. And we have y is less than or equal to negative 1/2 x plus 2. Now this is why I chose 4 instead of 3, because I wanted this fraction to become an integer. So there's some things that we can note. First, that y-intercept is a positive 2. That means we want a y-intercept that is above the x-axis. The slope is negative 1/2, meaning it's downward sloping. And we see that y is less than or equal to negative 1/2 x plus 2, which means that we're going to shade below the line, not above it. So taking those three things into account, let's look at the answer choices. F, we have a positive slope. Even though we have a positive y-intercept, this is not our answer. In J, we have a negative slope, which is what we want, but we have a negative y-intercept, not our answer. G, H, and K have negative slopes, but H has a negative y-intercept, so that is not the answer. We have positive intercepts on both G and K. The thing is, with G, you are shading above the line, whereas with K, we are shading under. So K is going to be our answer. Number 57 is an integrating essential skills question. It involves multiple steps and setting up equations. The art club designed and made banners of the school colors, blue and white, for their fundraiser. Each banner required 1/4 yard of blue material and 3/8 yard of white material. The club originally planned to purchase exactly enough material to make 500 banners, but found the material to be cheaper if purchased in full bolts. The blue material in 10-yard bolts and the white material in 12-yard bolts. How many extra banners was the club able to make if they purchased enough full bolts to make at least 500 banners? Now first we have to take the blue and white banners separately. It takes 1/4 yard of the blue material and 3/8 yard of the white material. Each banner takes 1/4 yard of blue material and 3/8 yard of white material. And we can figure out how many yards of each material we need by multiplying 1/4 and 3/8 by 500 respectively. So we need 125 yards of blue material and we need 187.5 yards of white material. Now we're buying the material in bolts. The blue material is sold in 10-yard bolts and the white material is sold in 12-yard bolts. In order to have enough material, we need to buy 13 of these bolts in blue. 12 would not be enough. We need 13 to give us 130 yards and we'll have some remaining. In the same way, with the white material, we need 16 bolts. Not 15. 15 wouldn't give us enough. 16 will give us 192 and we'll have some remaining as well. The blue, we have 5 yards remaining. And with the white, we have 4.5 yards remaining. With that remaining amount, we can divide the 5 yards of blue material by 1/4, because that's how much it takes for each banner, and we'll get 20. We can divide the 4.5 yards of white material by 3/8, and we'll get 12 banners. So how many extra banners are they able to make? Well, they can make 20 with the blue, but they can only make 12 with the white. So 12 will be our answer, A. Number 58 is a number and quantity question. This question deals with multiplying polynomials and working with the imaginary number I. For all real numbers x and the imaginary number I, which of the following expressions is equivalent to x minus 3i quantity cubed? X minus 3i quantity cubed is the same thing as x minus 3i times x minus 3i times x minus 3i. So what we want to do first is do the FOIL on those two binomials. So first is going to be x squared, and then minus 3ix inner minus 3ix last plus 9i squared. These middle terms we can combine. That'll be minus 6i x. And this I squared is really negative 1. I is the square root of negative 1. I squared, which is I times I, is the square root of negative 1 times the square root of negative 1, which is just negative 1. So if that's just negative 1, that's 9 times negative 1. That would be a minus 9. At this point, we are going to multiply this quadratic with this binomial. So that's x minus 3i times the quantity x squared minus 6ix minus 9. I'm going to distribute the x's to each term first. That's x cubed minus 6ix squared minus 9x. Then I'm going to distribute the negative 3i to each term. Minus 3ix squared plus 18i squared x plus 27i. We want to look for like terms. We have an ix squared here, ix squared. So this is x cubed minus 9ix squared. At this point, we can go to the answer choices and see that there's only one answer choice with a minus 9x squared I. So this will be our answer. We can also see that this term can be added with this term. That I squared makes this a negative 1. That's 18 times negative 1x. So that's negative 18x. So that's negative 9x minus 18x, which is minus 27x. And the last term is plus 27i. That is our answer. I would say this part is the trickiest, but you don't even need to do that because at this point you know what the answer already is. Number 59 is an algebra question, and here we are evaluating a function. The graph in the standard xy coordinate plane below is the graph of one of the following functions. Which one? To solve this problem, we want to keep two things in mind. First, we want to keep in mind what a quadratic function looks like. It's a parabola. We see that the end behavior is in the same direction. A cubic function, on the other hand, looks like this. You see that as it approaches positive infinity, it's increasing, but as it approaches negative infinity, it's decreasing. It has opposite end behavior. Now let's look at the zeros of this function. They happen at -4, 0, and 6. If we look at 4, we see that on one side it's going up, but on the other side it's going down. On the 0, both sides are going down, and at the 6, one side is going down and the other side is going up. Here we can deduce several things. First, if we look at the 0, we see that both ends are pointing downward. That means it has to be an even function. So if we go to the x's, we see that this is x to the 1. That's not going to be our answer. And we have x cubed over here. That is not our answer. B, C, and D all look very similar. The only thing is that x plus 6 doesn't have a cubed. So let's see if that's significant. If we go to the 6, we see that it looks very similar to this cubic function. And that's because locally it is cubic, which means we do need a cube there. The answer is not B. C and D look very similar. The only differences are the plus and minuses. So the question is this point x plus 6 or is it x minus 6 quantity cubed? Well, it's the point x equals 6. If we were to express x equals 6 as a binomial, that would be x minus 6 equals 0. So if we bring the 6 to the other side by subtracting, that's x minus 6 equals 0. Or if we bring the 6 back over, we get x equals 6. So it's going to be the x minus 6 cubed, which means that the answer is D. Number 60 is a number and quantity question, and we are dealing with matrices. The table below shows the number of rows and columns in each of 5 matrices. For distinct values of k, m, and n, which of the following matrix products is not possible? Now, you might not know matrices very well, but matrix products are very easy. The first thing you want to keep in mind is that we always express matrices with the rows first and then the columns. So rows by columns. For instance, if I have a 3 by 2 matrix, that is 3 rows and 2 columns. The rule of matrix products is that when you multiply one matrix, an R by C matrix, by another R by C matrix, the column of the first matrix has to be the same as the row of the second one. So what I mean by this is, let's say that there's a 3 by 2 matrix and you have a 3 by 3 matrix. You cannot multiply these matrices because those two inner numbers are not the same. Whereas if you have a 3 by 2 and a 2 by 7, those two matrices can be multiplied together because those two inner numbers are the same. The column of the first matrix and the row of the second have to be the same. So what we're going to do here is look at each of these answer choices and see whether or not they can be multiplied together. Note that usually on these types of questions, the later answer choices end up being the right answer. So the problem is made so that you have to test all of the answer choices. If we look at F, ED, E is an N by M matrix, D is a M by K matrix. These numbers are the same. This works. This is not our answer. And we can go through all of them, but in the end, the answer is K. If we look at A is a M by N, C is a K by N. These two numbers are not the same. That is why K is our answer. The product is not possible.